Hey, I'm Joey Savage, and this is a half stick of butter. And if you think about what butter is actually made of, it's actually 85% fat. So on a per weight basis, this is mostly fat, and I'm going to show you why things go higher in energy level. They'll transition from solid to liquid to gas. And that's exactly why I'm going to show you why thermogenesis is an important factor of lipolysis and fat oxidation on this episode of the Supplement Lab. How's that butter looking? Pretty good? So, needless to say, a little bit of heat can go a long way with some fat. And just for a little extra added stunt along with this whole episode of Supplement Lab featuring Slyce, I'm going to be ingesting this capsule, and this is a gelatin capsule, so I'm going to get immediate release of a whole bunch of black peppercorns in here mixed with some actual bioperin, actually more than 5 milligrams, which has me a little scared, but not too scared. But what does have me scared is this. The Capsicum annuum, and this thing's going to have real live capsaicin in it, and I'm going to eat this too. And then I'm going to take these guys and combine it with a pretty darn heavy dose of niacin. So I'm going to turn red, and I'm probably going to get a little thermogenic throughout this entire video. So stay tuned, and here we go. I ain't eating the stem. I'm not going to like this. All right, bring it on. We're still on?
Yeah.
Okay, here we go. That was fun. My mouth is burning, and I'm gonna explain a little bit more about that here a little bit later. So let's get into the ins and outs of this beautiful baby Slyce and why this thing is gonna help you in burning more fat. Now, fat in as far as this metabolism, oh boy, is concerned is this balance or tilting of this balance between lipolysis, the breakdown of fat, and then the actual lipogenesis, the creation of new fat. And this requires a few different things. One, it requires you to breathe, because you're going to be taking in oxygen from your environment, and that's going to get transferred to all your cells. It participates in cellular respiration, but it also participates, oh, I'm salivating, in beta oxidation. And beta oxidation is the actual breakdown and chopping up of fats. And when these fats get oxidized, they become CO2, and you exhale them. And I might even have fiery breath after this. Second thing you're gonna need is an increase in heart rate. Now this increases metabolic processes more quickly on a global kind of scale. Increase in heart rate is gonna translate to increase in metabolic rate as well. Third thing you're gonna need is sweat. Now, this is a process of production of heat by the body and also heat dissipation through the actual sweat cooling you down. So it's all about moving this energy and this heat to new places. Now, it's been typically said that fat burners don't burn fat, and I tend to agree, because the actual physical exercise is like a necessary requirement. You actually do need to be exercising in order for this to work. So if you're gonna end up taking this and not working out, that's probably a bad idea. If you are gonna take this, you should probably work out. And if you do, we could possibly help you facilitate the natural processes of lipolysis. So how do these things work? I will give you a brief rundown on the previous dogma of fat burning and how that works. Now, it's usually been done through two different mechanisms. One is through the thyroid hormone production pathway. Thyroid stimulating hormone can actually cause more uncoupling in the mitochondria. We'll get to that in a minute. But also there's activity at the alpha and beta adrenal receptors. Now, throughout time, our industry has lost more and more agonists of the beta adrenal receptors. However, we can activate the endogenous beta adrenal receptor ligand, which is norepinephrine. However, historically, all this has been based on using exogenous type substances, and what they do is they will bind to the same receptors for the endogenous ligands, and this causes activation of an enzyme called hormone-sensitive lipase that begins the lipolytic process in a fat cell. Now, caffeine is something that's going to be one of the primary components that's going to be getting you to the gym. It is involved in the catecholamine release of norepinephrine and adrenaline, also called epinephrine and noradrenaline, if you like using those words instead. But these, like I said, they elicit the fight or flight response, an increase in heart rate, an increase in lipolysis, an increase in breathing, all the things that are necessary for effective fat burning by binding to the beta-2 adrenal receptor. Now, as I said earlier, norepinephrine is the endogenous ligand. There are exogenous ligands, usually in the form of various alkaloids that you'll find in nature, like the actual alkaloids that are found in cocoa-butyrol, which have some activity on beta-2 receptors, but also the yo-yo combo, as I mentioned, from specimen, which is the 2-type-CO-HIMB that will antagonize the alpha-1 and 2 adrenal receptors. So then we've got evodiamine, which is the next alkaloid on this list. It activates the beta-3 adrenal receptors, but it also has some activity on the TRPV1, which is what the spicy stuff is kind of doing. However, activation of the beta-3 adrenal receptor, the antagonism of alpha-1 and 2, and then the activation of beta-2, all these things are going to work on the same pathway by activating hormone-sensitive lipase, which will begin lipolysis within the fat cells themselves. Next, we do include some kelp in here, which is not like it's an exogenous thyroid hormone kind of thing, but it does supply a little bit of iodine, and iodine is typically the rate-limiting factor in thyroid hormone production. Any deficiencies can cause a thyroid hormone deficiency, which can alter your metabolism. So as long as you have a sufficient enough, as long as you have sufficient amounts of iodine in your diet, you can produce enough thyroid hormone, which can also activate hormone-sensitive lipase, and this can affect more fat burning as well. Now my nose is running. Okay. Caffeine, back to that. It's something that also enhances fatty acid turnover. It does stimulate lipolysis through the activation of norepinephrine, which activates hormone-sensitive lipase. I'm gonna sneeze. And in combination with something like EGCG from green tea, which is also included here in Slyce, it can cause an interesting effect by increasing messenger RNA levels of hormone-sensitive lipase, so the abundance of this enzyme, or potentially the abundance of this enzyme, but it also increases the messenger RNA expression of adipose triglyceride lipase as well. So these are two different downstream effectors of the actual binding to the adrenal receptor on fat cells. Those are typical. Now we're going to get into the weeds. So I'm going to bring up something. It's called mitochondrial uncoupling. This is a not so typical form of activating thermogenesis inside of fat cells. What it is, it's an actual chemical kind of override of oxidative phosphorylation. Ooh, that's big. Oxidative phosphorylation is the typical route of breaking down carbohydrates to ATP and doing beta oxidation of fats into ATP. But whenever you undergo mitochondrial uncoupling through the activation of various subset of uncoupling proteins, that you can actually suppress this ATP generation, override this with an influx of hydrogen ions into the inner mitochondrial matrix, and this creates heat. Now, in extreme cases, it can cause a lot of heat, and the cell can actually undergo mitochondrially mediated cell apoptosis or cell death. But in addition to that, it just causes more of a physical reaction of heat. This heat that gets released instead of the actual ATP being produced is part of what is called non-shivering thermogenesis. And it's really kind of interesting that we touch on non-shivering thermogenesis because actually if you live in a higher northern latitude where it's cold all the time and you expose yourself to cold all the time, this actually increases your capacity of actually producing these uncoupling proteins to create heat via non-shivering thermogenesis and possibly override the need to actually create ATP out of your stored fat. Now, in addition to this, there's several different uncoupling proteins. There's about 5 of them. In brown adipose tissue, there's definitely uncoupling protein 1, 2, and 3. White adipose tissue typically has uncoupling protein 2 and uncoupling protein 5, but in some rare cases you can actually stimulate uncoupling protein 1 in brown adipose tissue, which we will talk about. All right, so I just touched on the uncoupling proteins in these many different kinds of fat cells. However, I'm going to tell you about 3 different kinds of fat cells. There's really actually 2, but then there's like one that's kind of like in between as far as the ones you actually have. Now you have white adipose tissue. This is the fat cell that is closest to the skin. If you actually like stretch your palm and look kind of hard, you can kind of see it through your actual skin tissue. Those little white globules are little fat cells that are just sitting there chilling next to the skin. You have the beige or browning fat cells, which are white adipose tissue that have undergone a few morphological kind of changes. They've got more mitochondria, they have smaller lipid droplets, and they're on their way to becoming a BACT, or a brown adipose tissue or a brown adipocyte, these have actually several mitochondria, many small lipid droplets, and they're actually located close to the muscle. They share a little bit of muscle protein morphology because they express myogenic regulatory factors, but yet they are still a fat cell. But they also live coincidentally right next to the muscles, whereas the white adipose tissue lives next to the skin. And if you can imagine, this is actually an interesting spectrum where all the way over here on the far left, you've got stuff that's actually fairly cold because it is next to the skin. And if you actually consider the brown adipocytes in the muscle tissue, these are actually warmer cells themselves. And it's no shock that these things are going to be able to express more uncoupling proteins. Now, the way that we're actually triggering these uncoupling proteins here in Slyce is through two different mechanisms, or actually two different ingredients. One is fucoxanthin, which is extracted from various types of sea algae. But it is something that is a carotenoid, which is usually a color pigment, but there's something unique about fucoxanthin that's really unmatched. I mean, it's got a unique structure, being a xanthophil instead of a typical carotenoid, and because of this special unique structural composition of fucoxanthin, it's able to do things that other carotenoids can't, like activate uncoupling protein 1, which is a very rare case that I actually mentioned earlier, in white adipose tissue. Now this is really cool because if you can actually cause more heat generation in these tissues, you would probably increase the likelihood of them making the transition into the beige state. And if, you know, enough luck, they can transition into the brown state, and then they can actually be burned way more efficiently than they are in being a storage site far, far outside from the core. Now, the other thing that fucoxanthin does is it inhibits a gene pathway called PPAR gamma. And I have actually touched on PPAR gamma a little bit previously in Cheat. PPAR gamma is the master gene regulator for adipocyte differentiation, the creation of new fat cells. So by blocking PPAR gamma, we can actually stop that signal. We can make the problem not get any worse by stopping it, you know, right there in its tracks. So by inhibiting adipocyte differentiation, by blocking PPAR gamma with fucoxanthin, we can at least stop the problem from getting any worse. Now, the second thing that we include is pyridoxine plus, which is a new specification of the old traditional pyridoxine. This is several different names. There's Aphromoma melegueta, which is one of the names. Another name is grains of paradise. Some people call it the guinea pepper. Some people call it the alligator pepper. But I can tell that you can understand that based off of these other things that I've done, you can tell it's spicy and that it'll probably have some sort of a similar mechanism as that weird stuff that I ate earlier. So another thing about pyridoxine plus are the compounds that are found inside it. It can increase uncoupling protein 1 and uncoupling protein 3 in brown adipose tissue. So we're hitting the uncoupling protein here. This is actually fairly easy because they pretty frequently will express these uncoupling proteins, and they go through this way more frequently because part of the brown adipose tissue's job is to make sure that your internal organs are in a very nice, happy, safe temperature span. So they don't end up getting like too cold or too hot, and they're just kept right in that zone. Now, another thing that pyridoxine can do because of the different compounds that are found inside of it is it can also activate the TRPV channels that I've been chomping at the bit to talk about through this entire video, and I'll do that now. So, the TRPV channels. How many three-letter acronyms am I going to throw out here? Quite a lot. But the TRPV channel is the transient receptor potential vilanoid receptor. No, not like vanilloid, like a villain or vanilla, it's just its name. But what you can see is I've got a list of all the agonists here that are actually found in Slyce right in this chart for a side-by-side comparison. Now, the actual vanilloid component, and Spice is really getting me, is right here on the far left. It has a hydroxyl group that is completely para to the entire rest of this chain. In the meta positions, we have a methoxy group, and that is also part of this vanilloid thing, and this is all on a benzene ring. And this is the actual part that is responsible for binding to TRPV1. But you can tell that since 6-paradol, 6-shalgol, and 6-gingerol, and zingerone all contain the same vanilloid group, you can tell that these things will probably have similar properties. But they're not near as good as the reference standard of capsaicin. So we'll get to that in a sec. Let's just talk about what the TRPV1 receptor is really responsible for. It's found in your mouth, your stomach, your intestines, your entire GI tract. And it's responsible for that feeling of spicy foods whenever you eat it. It's also in your sensory nerves, which are working in concert with the GI-based receptors to where If you get some activation in the GI, it hits a nerve in proximity and says, okay, this shit is hot. Let's make a modification to try to cope with this kind of stress. Third place it's found is adipose tissue. How convenient. That's exactly what we're talking about this whole time, is fat. So what these receptors do for the most part is they detect things. These are environmental kind of sensor things, but it's in more so the internal environment than the external environment. It detects abrasion. Maybe you've eaten a really, really huge heavy meal and I don't know, you ate a lot of crunchy stuff. That abrasion on the sides of the intestinal wall in the stomach is something that will be detected by TRPV1. Now, also acidity. If you had a really acidic kind of meal, maybe a lot of spicy food, that increase in acid or decrease in acidity can actually be another thing that'll trigger TRPV1. Third thing is pain. No shock there. The fourth thing, obviously in association with pain, is heat. It detects heat and it can change its heat sensitivity based on the different things that are actually binding to it. And because of this, it's involved in energy homeostasis and thermogenesis as well. It's triggered by stuff in ginger, stuff in garlic, like the sulfur-containing different compounds that are found in garlic. It's also activated, obviously, by spicy peppers, which I've also talked about here. And it's also activated by, shockingly, jellyfish toxins. So if you're thinking about going out to that sushi restaurant tonight and having some jellyfish, I'd probably say make sure it's pre-workout, right? And don't die. That's the second thing. So any of these different things that are on this list are agonists of TRPV1. And what TRPV1 does in response to these different stimuli is it causes the receptor itself to form an open channel, and this open channel causes an influx of calcium ions to come into the cell and create an action potential. And this will activate a different protein called calmodulin and the calmodulin-dependent protein kinase. And this is something that will trigger AMPK. And I talked about AMPK a whole lot in the cheat video. And AMPK is something that says, oh man, the energy is really low in here. We need to create more ATP. Protein synthesis and all you syntheses over there, we're gonna shut you down for a little bit because we really need ATP really bad. So it will shut that down. And another thing that it'll be activated by is just a simple imbalance in the AMP to ATP ratio. If the AMP levels are higher than the levels of ATP, that's another trigger. Now, this can also happen through caloric restriction. You're not eating enough, so the ATP levels are low and the AMP levels are high, and that activates AMPK. Also, strenuous exercise can do the same thing, but it does it in a different kind of downstream effector where it activates something called LKB1 before it'll end up activating AMPK. Now, AMPK is really beneficial in fat burning, and being that it's a downstream target of TRPV1, it's pretty useful. Not only will it do things like activate sirtuin-1, which can deacetylate PPAR gamma, which is a negative regulatory process on adipocyte differentiation, as we discussed earlier, but it can also do a couple other different things, like I said, like inhibiting fatty acid synthesis, cholesterol synthesis, and protein synthesis in favor of fat oxidation. TRPV1, coincidentally, can also activate another gene pathway related to PPAR gamma called PPAR alpha, and this facilitates further lipolysis and the oxidation of fats. And TRPV1 activation can also activate bone morphogenic protein 8 or BMP8, and this is also something that results in a thermogenic effect. So activating these receptors is something that can definitely help increase energy expenditure through triggering this kind of response. So how we're actually triggering TRPV1 in Slyce is mostly from capsaicin. Capsaicin is pretty well the gold standard in TRPV1 agonists. It's very, very well characterized and well structured. So capsaicin and its binding to the TRPV1 receptor is something that's been pretty well characterized. I've got a study here that shows really high definition imagery of TRPV1 receptor and where the actual capsaicin binds. This was done in 2016, and these guys have actually gone on since this paper and have characterized the binding affinities of these other guys as well, which is over there on the shelf. But anyway, going back to this whole thing, what makes capsaicin actually bind to these TRPV1 receptors sufficiently are three different criteria. One is the phenoloid structure, which I touched on earlier. The second thing in the middle brackets is this amide group. And the third thing is this fatty kind of tail thing that'll actually bend around and actually hang on to the receptor itself. Now, you see that 6-paradol, for example, the second strongest in this whole list, is something that kind of lacks that amide group, that second part, but it does have the third part and it does have the first part, which means that its binding is not going to be as intense as capsaicin, and it can potentially compete with it in certain scenarios. Now, going down the list, 6-Shalgal and Paradol, not a lot of difference there. They don't have the amide group. 6-Gingerol still doesn't have the amide group. And Zingarone definitely doesn't have the amide group. However, they do have the other boxes kind of to be checked there with the fatty acid tail and the vanilloid. So then we have these two other candidates here at the bottom of the list. And it would take some creative thinking to actually rotate these things around in your mind to try to see, okay, here's that weird little amide looking thing. And it's kind of like what goes on here. But what's interesting about piperine, which comes from black pepper, the BioPerine that is found here in Slyce, is that it requires a higher dose to activate the TRPV1 receptor. Now, capsaicin can be activated, can activate the TRPV1 receptor in doses less than 10 milligrams. It takes about 100 times the amount of actual piperine to cause the same kind of response in conjunction with capsaicin. Now, it's theorized that these things may not have the same binding sites, and because of this, it can produce more of an additive effect. Now, there was a study that was done that investigated doing the regular dose of capsaicin and then hitting the hammer with some piperine and seeing what kind of response that was elicited at the TRPV1 receptors. And you ended up with some sort of graph wherever capsaicin comes in and causes like a bloop in TRPV1 receptor activity, and then they added piperine to it and it went whoop, whoop, and then came back to the capsaicin level, which is kind of interesting because there's not a whole lot of studies that are out there that really consider looking at multiple ingredients working on the same receptor at the same time. So I thought it was pretty fortunate that I was able to find this and not only find that black pepper, aside from its absorption enhancing cytochrome P450 mechanism, actually had a fat burning mechanism. And I'd heard through various, supplier mailings and stuff and their white papers and PDFs that this was actually a bit of a thermogenic, and this actually kind of explains why. And if you were to actually add it to something like capsaicin, that it could actually produce a higher intensification of this TRPV1 receptor activity. Second thing, niacin. Niacin isn't something you would expect to really be on this list. And because niacin's a B vitamin, what's it doing at these heat-sensitive receptors? Well, the authors that were actually looking into this potential mechanism were trying to find, why does niacin cause the flush? Surely it's got to be some sort of heat-related mechanism or vasodilation-related mechanism or something. And then they found out that, kind of like piperine, that it binds to a completely different site on an intracellular side of the TRPV1 receptor, where it will occupy this space, and it can actually, like black pepper, be co-administered with capsaicin as well. And this produces a substantially longer desensitization of the TRPV1 receptor compared to capsaicin alone. So with these two different things, with black pepper, we've got a higher intensity of desensitization at TRPV1, but we also have a longer duration because we're also combining this with niacin. So that causes an actual synergy here on the bottom, with niacin causing a longer duration of TRPV1 desensitization, but we have an additive effect that's here with black pepper because it just increases it just a little bit. So between these two, if you want to check out also this niacin, it's right here. Nicotinic acid is a common regulator of heat sensing TRPV 1 through 4 ion channels. You can check that out. So that'll actually detail this combination, this synergistic effect that I'm actually putting the S word on for niacin and capsaicin combination. And then the last thing I'm going to talk about is forskolin. Forskolin is something that's used in a whole lot of different fat burners because it binds adenyl cyclase that is on the cell surface, and what that does is it causes a rise in cyclic AMP. Now, cyclic AMP is kind of like the AMP I've referred to earlier, except for it's got this phosphodiester bond, but as long as PDE, or phosphodiesterase, is there in sufficient quantities and not inhibited by anything else, that it could possibly lyse this, cause an increase in AMP levels. This alters the AMP to ATP ratio, once again activates AMPK. And that is pretty much it. This is Slyce. We work on the adrenergic system to actually stimulate hormone-sensitive lipase activity. We trigger mitochondrial uncoupling so we get more heat out of it. We also activate TRPV1, and this is something that will downstream affect AMPK. And we also focus on the downregulation of fatty acid synthesis and adipocyte differentiation. So if you're interested in these kind of things being incorporated into your workout regimen by taking this baby in a gelatin capsule 30 to 45 minutes before your workout, check out Slyce. We'll see you next time on the Supplement Lab.